Okay, so Happy New Year, Merry Christmas. Today we're going to be talking about Android services. So without any waiting around, let's just jump into it. So before we start, we do need to recap a few other things because I find that services are a little confusing when you're trying to place them in the grand scheme of like what we've already gone through with activities and broadcast receivers and things like that. And we kind of want to understand their place in the ecosystem. So activities are in the foreground. They're usually something that the user is directly interacting with, so something that the user is clicking on, messing with, things like that. Broadcast receivers, which we talked about I think last time or the time before, those are used for talking to applications in the background, but they can also run a little bit of code and perform some operations. Services are different because they're intended for completing longer running background tasks. So things that would require more time than just, checking a number or making a quick API call, or depending on your definition of quick, things like that. So Android defines these as an application component that can perform long-running operations in the background without providing a user interface. They're typically used when an application wants to do some long-running operation where user interaction is not needed, or to provide some functionality to some other application. So hopefully that kind of clears things up, but we'll try and get around any other confusion. So services are not separate processes. They run within the same process as the application itself. So if you have an app that, due to its functionality, has like services that need to be running in the background, then that's something you would need to communicate to your user. A good example of this, which we'll talk about later, is a music player, right? If you close Spotify or SoundCloud on your device, the service is no longer going to be running. Again, it's the same process. And the same thing for threads. Services are not threads. It's not used to perform work off of the main application thread. Services are for the application to tell the system that it wants to do something in the background, and that'll correspond with calls to the start service method. And those are what's asking the system to schedule work for the service until the service itself or some other entity explicitly stops it. The services are a way to expose some kind of functionality to other applications. So in this case, you'll see this corresponding to this bind service method. So that's how we're going to be exposing services, is by services kind of operate in a default way that lets you interact with them, but there's also you can bind to a service and communicate with it. But that lets long-standing connections be made to services in order to interact with them. Like I kind of hinted at earlier, you might actually use this a lot. Imagine a music or a video player where you want the users to be able to download large amounts of data. You can use a service to perform this in the background so that the user isn't pestered to like watch something as it's downloading. Most music players, a lot of video players, implement these services so that you can play audio or video in the background while you're using other apps. I know like YouTube didn't used to have this, but YouTube used to have that functionality where you could listen to just the audio in the background, or you used to not be able to play in the background, things like that. When services are being implemented, they might look something like this. You'll see it declared in the Android manifest. Here's the name of the service, it's enabled, and it's exported. Here's the intent filter on how you can talk to it. Of course, as an attacker, right, we're most interested in these exported services, but just because this is exported doesn't really make it an attack service. Services can be protected by permissions like this. So in this case, this is like the bind job permission. That's typically used to schedule tasks for some other time, which, in this case, the bind job permission is a permission that only the system can use. So unless your malicious app requires system privileges, at that point, right, there's no point in even trying to compromise a service. You basically have the keys to the castle. So typically outside the threat model for these kind of things. But the attack surface for services is often seen as more complex because you'll usually have to do a little bit more reverse engineering to get a working exploit. And there's also added complexity with the distinction of the like bindable and non-bindable services. There's also local services that are limited to the app, and there's message handlers and even like idle services, which we'll talk about kind of towards the end here. This is what it might look like to start a service. So you have this on click, and this is my app example, right? using the onClick, create a new intent that's pointing towards this service, and then use the start service call that we mentioned earlier. The issue you can see here is it can't actually find this service. That's because anything after API level 30 or Android 11, we need to use these queries element in our manifest to actually say, hey, this is a package that we want to interact with when we're calling this service. So just something you'll have to keep in mind if you're using that version of the API. Then, after this, you shouldn't have any issues calling it. I wrote lifestyle, but I mean life cycle. Anyway, we can look at the manifest and find references to the service. So obviously, right, here's the manifest. It says, hey, here's the service name. It's enabled and it's exported. And here's the intent filter. Here's what we're kind of looking for. Unlock 1, 2, and 3. If we go ahead and look at that logic here, we can see that, okay, if it's looking for this start command, on start command, it wants some incoming intents here. And if it's intent 1, it'll set the lock to true. If it's intent 2, lock 2 is true. Intent 3, lock 3 is true. And if it's anything else, it'll reset all these locks. But if all 3 of these locks are set to true, then we get success. Great. Otherwise, it'll reset those locks. Makes perfect sense. All we really need to do is submit an intent to the service with the action set to the unlock whatever in sequence. You could also just rebuild your app 3 times, submitting lock 1, unlock 2, and unlock 3. But that's a little bit more tedious. So here's an example, right? When you click the button, it will cycle through 0, 1, 2, and 3 and unlock the service or send this unlock intent each time. And then each time it's starting the service. So far, right, this doesn't play that much differently from when we were messing with broadcast intents, right? It's just a different way for us to communicate with the application. And obviously, right, we're still using intents because there's data traveling along these paths. So it's really, in that way, it's nothing that we haven't seen before. It's just a different mechanism that we're messing with. So that'll work. And you should be able to get that flag without issue. So you'll see it presses the button. You can see lock 1, lock 2 are true, lock 3 is false. We send lock 3. It prints us the flag, and then we get this stuff, earlier. But you get the idea. I think next we're going to talk about bindable and non-bindable services. This is where I quite frankly get pretty confused, but it's something that we do need to talk about. So a normal service is typically just started for the purpose of executing something. Bound services are where the app can establish a connection and continuously exchange data with some other app. So this binding is what's happening when we call the bind service function. We talked about it, or we had it in that image way back then. Non-bindable services appear similar, or they act similar to broadcast receivers, which makes sense because they execute code in the background once you call them. The only main difference between a non-bindable service and a broadcast receiver is that the services can run for a much longer time. So once you've found an exposed service, you want to see if you can bind to it, because obviously, right, if we can't bind to a service, we can't do that continuous interchanging of data. So non-bindable services naturally aren't as interesting to us. However, if it kicks off some sensitive action, that might be something you want to look into. But again, it depends. You can look at this implementation, and even though we have the onBind method created, so the class might appear to be bindable. In this case, right, it's not implemented. It gives you this exception whenever you try and bind to the service. So you might also see services where the onBind method returns something, but only from an internally bindable service. So that would essentially, in our perspective, make that non-bindable because we can't impersonate the application itself in that case. The next thing we can talk about is message handlers. So these are a type of service that you might see implemented, and it's done so with this messenger class, which is something that's implemented as part of Android. You just have to import that class. It's not dissimilar to Toast or something like that. So if you see an onBind method like this that returns this messenger object, that's how you know you're dealing with a messenger class. In this example, the handle message method here implements the actual logic, which is like it's looking for this message dot what if it's equals to 42. So that's what we're actually looking for. We'll look at this example a little bit later. Actually, we'll look at it right now. So you can see it's a service that's exported and it's enabled, this flag 26 service. We look in there, you can see message.what here, which is, where's that on bind method? Here we go. It's using this messenger. And we can see that the all we need to do is set the what parameter to 42 in order for that to work. So the message code is it's a user defined parameter. So all we need to do is make our app talk to this using the message handlers. This might look a little confusing at first, and that's because it kind of is, but Android Studio at least will create like half of these weird little edge cases for you, like the try catch and this on service disconnected method as you create this first one. So all we're doing here is we're creating an on service connection method here that it wraps the iBinder service or the iBinder with a messenger. So we have the service messenger. We set our message to have null, and then the what is set to 42. We use the service messenger that we just created to send that message. And then down here, you can see when we have this bind service call, because I'm not sure if you can see, but on bind, you can see we should be able to bind to it just fine as long as we're using a messenger. So this is the specific way that we would do that. We need to use this service connection and attach our intent to this in order to communicate with it. You can also reply to messages. In this case, it wants where is it? In this case, you can see there's echo 1, flag 3, password is 2. It wants you to supply a specific message, and it'll echo it out to a little toast message here. It'll create a random UUID for number 2, which is get password, and it'll write that random number to the password field. And then in order for you to get the success call, you need to, let's see here, submit, the echo needs to be give flag and the password needs to be equal to the one that was set here. And that's how you would have to get the flag for this. So to practice that, or to just kind of show off what that would look like, let's see here. All we're going to do is we create our intent, we bind our service to it. This is kind of cut off because I couldn't fit everything in a good screenshot. But you can see here we're creating this message, message reply, string password. We're sending this first command here using, where is it? Service messenger send message. And this is all done on the click of a button, so it's a little confusing. This looper, I think, we had to send the third command after sending the password, so it was a little tedious, but you get the idea. We just create this 1, set it to give flag, create 2, make sure that we capture that message reply, write it to a string, and then send it with number 3 as the password that we're sending along with it. And then that'll get us our flag without any issues. The last thing we're going to talk about are AIDL services, or AIDL is what I'm going to be calling them, but it's the Android Interface Definition Language. These are used to define interfaces that can be used for inter-process communication. We've already kind of looked at how messages are a good way to implement IPC, but using AIDL can provide a more versatile interface for communication, or like I would say more granular, maybe not more versatile, because you have finer control over what exactly you want to be doing. To identify these, normally you would just go and look at the onBind method, and we can see here, it's returning you this bindle, and there's this iFlag interface, stub binder, which if you were to actually go and look into this iInterface, you would see a handful of more complicated methods. First, what we need to just look at is the service is bindable because this onBind method does return something, right? This isn't just that exception that does nothing. And second, this stub here is an indicator that developers implemented something using AIDL. AIDL reads relatively similar to Java. When we should be able to reverse engineer the AIDL file, which we would need to call these, but it's pretty easy to get those. And when you build an app, or another thing to talk about, it won't be in the reversed file. This is because when you build the application, the Android SDK tools generate the iBinder interface file based on the idle file. So this resulting Java code is like what we would see in the this decompiled code in JADX. So while the input might have just been like Boolean, open flag, in this case, we have all this other stuff with it. So where in reality, this and like 2 other lines might be the only thing being used here. So now you might be thinking, okay, well, like, it's fine, because in this case, we kind of knew what the idle definition was, but we might need to reverse engineer these in the future. So let's say, you see that stub thing called out for an interface, and we want to go figure out what's actually going on. Did it not? Oh, I don't think. Are these not the same image? These are the same image, aren't they? Yeah. Okay, that's a bad example. But let's say we build an image using stub. It was created with an idle file. Let's look at flag 29 interface as a good example. You can see here, this would be like the idle file that we would reverse engineer. And then this on the right would be the like what we can actually see when we decompile the APK, right? Because when we build the project, Gradle turns this, or the Android SDK will turn this into all this junk on the right. So what I will talk about is how come these things are the only thing we're looking for. So the methods themselves, when they're created in this way, they can't have method bodies because they would be overwritten in like the compile process. And they also need to throw remote exceptions. So this is an easy way for you to just reverse engineer the idle file, right? You look for anything that doesn't have a body and throws these remote exceptions. In our last example, we had this open flag was the only method, and it was a Boolean. So that's all you needed to know. In this case, we know that the order is init, authenticate, and success. So we know that string init is the first one, void authenticate, the input being a string, and then void success is the last one. So we would reverse that. We know this is wrong. This should be flag 29 interface. And then we know that this package is correct just from reading the descriptor here. So this is us kind of reverse engineering the idle file. And if that wasn't enough, you could also kind of validate this by looking at the binder communication. If you scroll down in that same file, you'll see some of these instances of where this is being used, like 1 obtain 2, 2 obtain 2, 3 obtain 2. So you can see the success, authenticate. You can see they're throwing a remote exception. These ones have a body, but these are generated. Those aren't part of the idle file. Now you might be asking, okay, well, what can these do? Can we even execute with this information? The answer is yes. It's just a little convoluted. First, once you've kind of reverse engineered the idle file, you need to first go into your Gradle, your build.gradle.kts file and add this little function in here. Then you need to resync your project so it knows that you're wanting to use some idle. Then all you'll need to do is right click this like idle directory. And then just I think type in whatever name of the directory or the name of this idle file you want to create. It won't create extra directories, but once you run the application, it will. Once you run the app to build those files, then you could just, in our case, right, we just modify our existing activity. So we have this intent that we're creating. And remember, flag 28 was just this open flag thing, right? So all we're doing is we create this connection the same way we have before. But in this case, now that we have this flag 28 interface built into our application when we're running it, we can just call that method definition. It knows that open flag is a Boolean that we can use. So all we do is say, on service connection, run this remote service, run open flag against it. And then the rest of this is kind of boilerplate. So you could probably already see how we would solve this, which is just by running each of these 3 things in order. And that code would not be very complicated either. It would just be replacing, 28 with 29, adding that idle file to our definition, making sure it's sending it to the correct class, And then all we would do is instead of it being remote service, we would just say like, string password equals remote service.init, remote service.authenticate as password, and then remote service.success. So it wouldn't be that much different. Wouldn't really be worth going over. Before I conclude, or kind of as I'm concluding, I was unable to find a lot of good CTF examples for this topic aside from those provided by the Hextree course that we're kind of covering. There was one from Mobile Hacking Lab, but the exploit wasn't so much the service itself. It was that there was a service that you can investigate that would reveal functionality that let you get remote code execution, but we didn't have to actually interact with the service itself to get that to work. So I felt like that was kind of a poor example, didn't want to include it. But anyway, our conclusion is basically the same as it has been the last couple, right? Export services carefully, make sure that you're, to protect your apps, you're only exporting things that absolutely need to be. Make sure you're following, the best practices with safe intent handling, safe input handling. Make sure that users can only, that other apps can only manipulate things that they should be manipulating. Make sure that your exported components are minimized in their functionality to achieve their goal, and make sure that you're using custom permissions where you can, because those can prevent other apps from tinkering with yours at certain points. But that's all we've got. Thanks for tuning in.